an overview of thermoplastic processing technologies. First of all, if we have a sheet, we can go and do the folding. Now, you've seen the folding with your lighter. It can be done also in a more controlled manner with a machine. That's one thing to do. And like I said, it's on this rudder, 1997. The green part in the back is folded. In the middle of the picture, green is the ribs that are stamp formed. And that's the next. So we can also make ribs. And here is a rib, for example, made in a press. You start with a flat piece of material. You go into an oven and you form this shape. A low-cost way to make many of these parts. And here's a picture. Years ago, this was done also in an autoclave by laminating prepreg and curing in an autoclave. Today, there's an ever-growing amount of companies that are doing this, and it can be simulated. So, to make such a part, like this rib, it has a complex contour, and the material, when it is shaped around the corner, it can give wrinkles in this area. Depends on the layers, depends on the tooling, tool design, and there is software available to predict very well what happens when you do this. Press forming is done with large machines, large presses that are very fast. On the picture on the left, you see several tools, 3 tools, to make 3 of these ribs in one stamp forming operation. The size of parts to be made in a press is limited by the investment that you can make. These presses are not cheap. So the bigger the product becomes that you want to stamp form, the higher the investment. So for really large parts, we tend to still go into an autoclave as a processing instrument. Then we have prepreg, single ply material, and we can make parts with prepreg. And we call this consolidation. And an example of something to make is the skins. And this is a skin for a wing leading edge. So this is a piece of a skin. It has a special layer on the outside, which is a mesh of aluminum in this case. These are layers of glass, thermoplastic, with different amounts of layers. So it's not one thickness, but as they say, it's tailored thickness, so different thicknesses. And this can be done by hand. For example, this gentleman, he's laying up with laser assistance. He is building up the skin layer by layer, and he is using something in his hand, and that's an ultrasonic tacking gun. So it vibrates very quickly, and in less than a second, it melts the material below the tip of his thing. So there's a generator, there's a booster, and a flat tip sonotrode, as they say, vibrating at a very high frequency. So the bagging of thermoplastics, in this picture, it is 2 skins for rudders and elevators of the Gulfstream aircraft. The bagging can be done with special films, high temperature films, but also can be done using very plain aluminum foil, pure aluminum. Aluminum is very soft, so a thin aluminum foil is used here to cost effectively bag thermoplastic products before they go into the autoclave. And then there's automation. You're probably all aware of tape laying and fiber placement for composites, very common on the large composite products in epoxies, in thermosets, and also for thermoplastics. That's the way we have to go. So some examples, a small robot making a piece here in thermoplastics, and a larger robot making a bigger panel in thermoplastics. There are different suppliers of machines, there are different heat sources, there is hot air, there is infrared, there is lamp heaters, there is laser, and there is ultrasonics. So different sources, depending on what you want to make. If the part has a lot of complex shape, then maybe a laser is the best way to do it. If it's a simple shape, you can do it with continuous ultrasonics. And here's a picture of a Dutch company that's basically using an ultrasonic technology that we pioneered some years ago. And what it does, it moves very fast on a track, horizontal track, to lay down thermoplastic material. 2-inch tapes, so 50 millimeters, cuts them at an angle. And with this machine, you can make the flat material to make parts in a stamp forming operation as a second step.